reading that little line, I will be arrested for not taking a fucking vaccine. This is not a fucking joke anymore. This is fucking dead serious. I am fucking dead serious. These people don't know who the fuck they're actually playing with. Yeah, in a group they might come and fucking intimidate me and whatnot, but fuck, they do not understand what the fuck just one person like myself is capable of. They do not fucking understand. No fucking vaccine or mRNA will ever flow through my fucking ball blood. Never! I will fucking die!
All right. Focus. It's still fucked up. I've done a reboot. Tell me, do I try and do the stream or do I just stop it? I'm about to get me lump hammer out. Start doing more remodeling. Is it working? Like I say, everything says fine. My end. The video looks fine. I can't hear it, but it looks smooth on Twitter. Rumble. Let's see. It's okay. All right. Well, I'll start again. So, I apologize that again there's been a gap in streaming, but I had the chance to take a trip with my eldest son. We got to well, it's a beautiful part of Japan, and we were visiting. Well, I'll tell people all my business, but it sort of culminated in a helicopter ride over a live volcano, which was pretty cool. So that was a few days driving to get there, a few days driving back, and hi, how can I say? Dajuba? Hi, sorry. All work, no play. Keep going. Yeah. Like I say, I was like, I'll take a break because, like I say, there's constant work. Them trying to just save the. Well, it's not save. They've done a good job of backside of the building. I mean, what was, this building it's 30 odd years old, and it was built initially as a cafe restaurant, but actually cafe restaurants make good conversions into laboratories. A lot of how should we say, sinks and plumbing and all that good stuff that you need, and it was well, it was a lot of work to get it converted, but so just more bills basically, because the job sort of has kept going and going as they've worked, and sort of they find more issues, and then my solution to the problem was, because the building is wood and the back side of the building was built basically as an open deck, and the people who owned this initially, the idea was that, in Japan you have cat cafes, and the idea, it was supposed to be a sort of dog cafe, and basically just the back, and it was all part of the same structure, right? So the foundation, the joinery into like this part, the working part of the lab, and all of that has had to be replaced. And so I instead of them building a deck, I basically said just seal it up and and I'll turn it into workable space. And yeah, it's a sealed deck's got a roof that isn't leaking, and you know, I can't ask for better than that. And the but you know, it's that was the guy who originally built the building, just handing me um the latest workup and the well, basic wish list. Can I have it sealed from the vicious Japanese summer and cold winters and typhoons and the earthquakes? And what else did it? What else did I have done? Yeah, so a hole cut in the wall for a ventilation fan, and that's basically it. No windows, nothing, just sealed shut, and then grounded, so it can't get stuck by lightning. I basically just had them put aluminium sheet, metal sheet, just all round it. The roof actually looks very nice. I went up on the scaffold and looked at it the other day, so hopefully it'll last another 10 years. Right, it all went to shit when I changed the view. Yeah, I'm sorry about that. Again, a very important stream because this, well, it's a confluence of events, right? That's enabled me to sort of take a what kind of builders did Doc hire? Literally they're the old dudes doing this work. It's the guy that the person that just handed me these workup sheets. He built the original building, and the original building is excellent. Like the part that wasn't exposed to the weather, it's in pretty good condition, and has taken conversion to a laboratory extremely well. It's just that back part. But anyway, today is an important stream because we've had this. I've been we're lucky, and I mean that we're lucky because if you've been following me and what I've been talking about and trying to work out for 5 years, has I feel that we've got a breakthrough, right? And the breakthrough is based on sound physiological mechanisms. It has construct validity, meaning that it satisfies what we understand to be the pathology with respect to SARS vaccine injury, and what I adamantly still hold the position to, that this was all a consequence of biological warfare research. And in the weeks since being able to get this case, so this case are they are anti-tinkering, yes. So this was literally a subject that came to the lab, so I've been able to take samples, and so the chain of custody is as strong as it can be. The treatment paradigm is with the hospital that I've been collaborating with now for 3 years, I want to say, and a group that I've come quite close to, and we've all been working, devoting our time, and basically I've been doing it off public support. There's no big government grants coming in and saving the day for the public in this instance, and I think we're keeping pace with and are exceeding the the big institutions. And so sometimes you can have large epidemiological studies, and you can have a million people, right? But it can still be confounded. And sometimes a case where you've got a single subject, but if it's been studied to the at very granular detail, we can extrapolate from that and see if it fits the hypothetical framework that we've been building and the results that we've been uh, um, able to generate. And these results are not insignificant, whether it's the classification of the calamari clots as large amyloid structures that are coming out of cadavers. And I'm supposedly supposed to be getting in the post the samples that have been taken from live individuals who have been undergoing procedures in cath labs. Again, it's are these different to known white clots that were, but that apparently made up 15% of known clots pulled from cath labs prior to COVID? There's many answers and work to be done in that domain. That's not my job. My job is to understand the neuroscience related pathology and how it relates to weaponized amyloids and them seeding the environment with these with the fallout from this biological warfare. And so I we'll look at a slide again in a minute, and that slide came up in the last sort of few days, which basically said to me, as I was sitting on this data, that I should put it out right now so people can come to this stream, see the data for itself, and if there are many people who have been hurt, and the ones that have gone already, but it's let the dead bury the dead. But for those that are still kicking and screaming, and some people have been pushed to the edge with respect to their kicking and screaming, being gaslit by the authorities, whether they've their tacit admission now that it was out of control research programs, as Trump said at the UN. I think that rabbit hole goes much deeper. But what I can do in this stream is explain some of the signals that we've seen with respect to known pathology that we've been discussing for many a year now, to a radical change in the appearance and the health of the blood in this instance. Now, does that mean it's cured everything, and is it a permanent fix? These are questions that we still need to investigate. I will do my best to keep everyone informed of the progress, but I just think it's important that as we get these findings out, I'm not concerned about putting it into a manuscript and getting another little academic good boy point on my CV. It's more important that it reaches people who have been hurt, basically, by what these assholes have done. So let's see. People giving me error reports. I'm sorry, man. I don't know what to tell you. Right? It just. I'll try switching to the main and see what happens. But here, right? So as I was saying, our understanding of the pathophysiology as has been it's out there in the academic literature, but we've kept track with that and have also been able to probe into the more extreme presentations, like the large amyloid clots pulled out by Richard Hirschman. They're not nanobots. It's very straightforward biochemistry, pathophysiology, once you understand what's going on. Okay. And I'm going to show you data today that shows that we've been able to reverse those signals, okay, the pathological signals. And the only reason I'm able to do that is that blue button down below, okay, is it's kept everything going for more than 5 years, and we're at this point where I can not only talk about and show regularly the pathophysiology, but now the reversal of that assault, man. That's how I look at it. It's assault from the people that were part of these programs that quite literally should be subject to military tribunal, as far as I'm concerned. So I'll presume that the chat. Hang on, I need the restream one, don't I? Copy. This. When's it? Why won't it let? I don't want the paste reference. Let's do this. Main reference, and if I do this, I don't know. Like I say, I'm kvetching so strong in the last stream just because I'm finding streaming very much a drag at the moment because of these technical issues, and I've literally, folks, I've had enough, particularly when what I should be doing is working towards and nailing down the reversal of the assault that I was talking about, which manifests as this amyloidogenic cascade within the blood, within the body. So that blue button, please, if you want to help support the stream, support the science, and importantly for this stream is if you have been hurt or you know someone who has been hurt, it's possible to get a measurement on the potential causes of your injuries. Okay, you don't be gaslit by know-it-all medics who are just wet behind their ears outside of just out of medical school, labeling you with a functional neurological disorder. There is a well-defined pathophysiology that we can identify right now, and we can get a measure of in the lab should you wish to send a sample. Okay, you need to go to this link. I have to put it in. I just put it there, right? And we're about to radically improve our diagnostics in the lab, where the amyloid burden test that we've been working with is lacked the ability to quantify and was subject to my eyes being able to see if there's the a pathology that can be detected. But Wednesday, it'll take some work to set it up and get it working properly, but we'll have a mechanism for being able to quantify the signals in the blood with respect to amyloid microclots. Now, funnily enough, the signals that we're going to look at today are ones that I don't talk about very often, and I'll explain them when I get into the presentation more. But it relates to autofluorescence of samples and blood that has a inflammatory phenotype, or it's carrying a lot of inflammatory signals as well as misfolding proteins, will autofluoresce. And it's that measure in this instance that we're going to be looking at, and shows the impact of the interventions that we've made. Okay, so what motivated me to just sort of start, usually I would like more I want more subjects before I start talking about results where we're saying we can fix some of these issues. But like I said, I'm confident that because everything has been done in the lab or close to the lab with the institutes associated with the work that we're doing, I'm prepared to sort of speak about it. And it's because of this particular graph. And as the people, again, the project halos, or the Spurgs like Henjin, who will say everything's normalized. This is the civilian labor force with disability 16 years and over. And this is from the US Bureau of Labor Statistics, civilian labor force. And here I'll put the link should you wish to go to the source of where they've pulled this data from. Hang on, it's this link, sorry. And I'm pretty confident that the reason for this radical rise in people being unable to work is not because they don't want to. There are people live these days hand to mouth, caught in debt traps, and it's incumbent upon them. And the what I see with people sending me samples is it's often people who have run through the medical system, and they're unable to work and have no options left, and again are being gaslit by a medical system that I think right now are doing their best to avoid talking about why you're seeing, and not the pathophysiology, but the causal reasons that this pathophysiology has emerged, and it's these biowarfare programs. But this almost exponential rise in morbidity that you're seeing is, and it's important data because people get caught up in deaths and what have you. And like I say, let the dead bury the dead. It's the living and those that have been hurt that we should be focusing on. And if we can address the underlying pathophysiology, which is this microclotting phenomenon in the blood, okay, then we stand a good chance of being able to reverse these awful casualty figures, is how I would describe them. And this pattern is repeated across many countries. I mean, it's a while since I read the review, but they're talking about hundreds of millions of people globally being afflicted at this stage. So, um, with this in mind, and of course, this I spoke about earlier in the week. So, from Aussie 17 has sort of annotated the graph, and this is riluzole, and where's the doesn't look as dramatic. It's sort of the cut the rise out. If I go to, let's see, profile applies. That one. Yeah, I think in this, was it Thomas did this? I can't remember. If I could find the original graph, I mean, it's worth it. It's the last stream that I did, which is prescriptions for ALS, a severe amyloid prion-like disorder, have basically shot up exponentially in line with these figures here. So I want to switch to PowerPoint quick. Okay, so maybe I'll take a little bit more time, right? We'll talk a bit more about clots. So clots in extremis, right? So as well as and I'm not talking about these large calamari clots, but I just see these as a continuum of a cascading amyloidogenic effect that is, I think, manifesting at a population level. And here we can see an example. Just quickly remind everyone that we've done the genomics to prove that it's of human origin. We didn't really find any examples of vaccine-related signals in the samples we looked at. That will be a primary focus in the coming months, waiting for Commander Rixey to get here. But just a quick look at what a large amyloidogenic clot looks like. You can see it looks relatively solid once they've been pulled out of the body. When you look at them under the microscope, they have a more fibrous, matted appearance, and you can see that they have this autofluorescent property. And here you can see it compared on the left-hand side after it's been dyed with thioflavin. You get this sort of polka dot appearance, and you also get these sort of twisting fibrous structures in there. You also see these in people's clinical samples that sent to me, these smaller microclot type presentations. Here they just seem to have, and I don't see any, there's no reason biologically why they can't just keep aggregating, particularly if the amyloid protein that's, or the protein that's become amyloidogenic is one that is well, it's in its normal condition is evolved to form large structures to plug wounds. Okay, and so a misfolding protein of that category in a essentially large vessel system like the circulatory system has the potential to form into large aggregates, quite different to how we normally think about amyloid buildup in for example, central nervous system, just to show what it looks like using scanning electron microscopy. It's similar to what's already been published. It's like I said, as an open source laboratory where we're trying to do everything transparently. Where our results are tracking with the highest and quote unquote most prestigious institutes on the planet. One where I used to work. This manuscript comes from UCSF. And potentially we see these aggregates perhaps being transferred in utero. These are images that I've taken from a child who was exposed in utero, came out. He was dead on arrival, resuscitated, has essentially immune dysregulation as part of his first 3 to 4 years on this planet. And there were significant aggregates in his blood, as far as I could tell, with thioflavin staining and looking at it with scanning electron microscopy. But part of the work, that's just one part of the work that we do, and the other is trying to look at the clotting mechanisms. And what we've been able to do using this type of apparatus, one where we were testing real-time quaking-induced conversion, which basically means we were looking at those large amyloid clot structures and seeing if seed amounts would be capable of causing an amyloid cascade such that it would have features that we would associate with more canonical diseases like scrapie, for example. And lo and behold, what we were able to see is that in a couple of examples, we see exponential rises when you add a seed amount to plasma. And it was this phenomenon that then allowed us to basically develop the test so that you could drop basically ultrasonicated amounts. So it's they're very, very small pieces. Again, seed amounts, but slightly larger amount volumes than we would use for RT-QuIC like studies. And this is just raw data. And on the left-hand side, let me just make that box. No. Where is format shape? Yeah. Doesn't it give you make lines? There we go. Didn't that used to be up in the toolbar? Let's see. There. So if I make that thicker, right? This one thicker. These are wells that we've used, and what we find, and there are experiments where they can auto inject without having to sort of break the experiment like we have to using this particular setup. But in the red, what you can see is that and when you take plasma and you add a catalyzing amount of that ultrasonicated clot, you see large peaks as you get this sort of cascading effect of the amyloid clots emerging in the well plates that you're testing. And you can try doing the same. And in this instance, we've been using stem cell growth factors to see if they're able to in any way modify the response of plasma to these catalyzing events. And what we see, and this is just raw data here, so the red is again, this is just a screen grab from the BMG software running the experiment, but the red is without stem cell growth factors. Blue is with stem cell growth factors, and basically any concentration that I tried, whether it's 25 microliters up to 75 microliters, all were effective at at stopping the increase in amyloid UV detection in these well plate experiments. But these were very much in vitro experiments, very, very far from translating to animal experiments or clinical environments. And now we've been able to apply stem cell growth factors, and in conjunction with some nutraceuticals, the molecusan, but too short range relative to how it's supposed to be used. And so the primary interventions were stem cell growth factors and double plasma apheresis, DPPF it's called. And it's a more aggressive form of trying to clean plasma out. And there are all manner of forms of apheresis. It has its limits in that it's again only filtering the plasma component, but what we were doing was large doses of stem cells in this instance, and then doing the plasma apheresis, followed by again large doses of the stem cell growth factors. And in this instance, what I was looking at and what was a standout feature of this this subject, which basically precipitated being able to test the interventions that we have available in this lab, which revolve around flavonoids and the stem cell growth factors, and then the physical interventions like plasma cleaning. And so what you're going to look at next is, this is just the blood slide, and just it's probably worth me just doing it in real time, just so it's part of this presentation. And you can see that in this particular individual there is a very, very significant background autofluorescence. And that autofluorescence, as I remember if it was the broken stream or this stream, where I was explaining the high background autofluorescence of whole blood was generally considered in pathology to be indicative of an inflammatory condition, and we will look at evidence that supports that contention in a minute. But I want to just show in real time what this blood looks like. So I want this. Gonna work? Yes. I will just gotta just set the scope up, so bear with me. So yeah, this is sometimes the camera does this, but it's actually a very, very interesting fault that I wish I could sort of have a button to flick it on and off, because it does actually show different properties to the blood. That isn't under fluorescence. That's just a fault in the camera right now, and it's but it I have to restart it. But what you're looking at is blood. This time you're getting a false color image. Basically, it's producing a false color image. Let me just restart it. Someone trying to grab my attention with. What is that? All right, I'm just working through people's. Do this. Just trying to keep up with the chat real quick. Yeah. Thank you, Tommy. This is the original graph from Aussie 13, showing the rise in Riluzole. Let's say maybe this last quarter of 2025 has been adjusted. Where did it go? Quarter one, and in this one we have quarter two, so it's been cut off the end. Is she showing? No. Anyway, back to this, and I still don't have a signal. Let's restart that. It says it's on. There's some fragments running somewhere. End task, please. Is that it gone? Yes, there we go. All right, is it gonna pick up the camera? Oh, there we go. Thank. All right, so you're just looking at whole blood, dried on a slide. Lowest magnification. Nice. What's it? Nice. Numerous microclots, and if we just look in the middle of the blood, this hasn't been dyed, and we just switch on UV. You can see that we have this very, very bright background, and it shouldn't look like that. I think it looks like I've put a drop of, maybe I put a drop of Fireflav in there. You can sort of see the microclots, but the non-dyed regions are very, very strongly autofluorescing, and that tells us that there's something going on with the blood in this particular individual. And I'll just switch back here. Oops. And that's what you're looking at here. And here, so you can start to sort of do some basic image processing so that it sort of helps the signal stand out. One second. But this false color imaging actually helps us check the difference between pre-treatment and post-treatment with the stem cells and the apheresis, DPFF. And this is after treatment, and this is quite a significant change, and one where the objection, I know what the objection would be, which is, well, it's just colors on a slide. It doesn't mean anything until you've quantified to some degree. Now we can, in effect, so this is examples of how the background microclotting looked in this individual. Oops. And generally, this is a crowded area of activity post-treatment with these amyloid microclots in this individual. And it all comes down to this data, which is we've been able to, once I'd seen the fluorescence, I was get a cytokine panel done, and we can see that there is significant levels of interleukin 1b, interferon gamma, MCP1, interleukin 6, interleukin 12p70, interleukin 18, interleukin 23. That's 1, 2, 3, 4, 5, 6, 7. 7 out of range cytokines, and fibrinogen was dysregulated, and in the pre-intervention measures, fibrinogen was low in this instance. And why is that? Well, I think it's aggregating into those microclots that we've seen, and the normal detection methods, again, are missing it in this instance. Well, not missing it, but it's registering as low because it's the protein that should be in plasma circulation isn't there and available for testing because of the amyloid aggregation. And so what happens when we, after we've done the treatment, so multiple large stem cell growth factor infusions with double plasma apheresis, right? Double plasma filtration apheresis, DPFF, I think it's called. Okay. And are there signals as to, or are there reductions that could account for the loss and change in the intensity of the autofluorescence? So let's just see. We had 1, 2, 3, 4, 5, 6, 7 that were out of range, and now we only have 4 out of range. And let's just go with the first one. So interferon gamma. In the pre-treatment measure was 30.2 picograms per mil. Post-treatment was 19.7. So it's only just out of range, with the normal range topping out at 17.09. And what was the other one? MCP1 in the post-treatment is 464 picograms. Pre-treatment 635 picograms, and the other one I want to say was interleukin 23, right? And 18, yeah. So interleukin 18, 297 post-treatment, Pre-treatment, 302, not so much a change there. And interleukin 23, pre-treatment is 43.2 picograms per ml and it's dropped to 31. So still out of range, but in effect, this is the first iteration of treatment that we've been able to do. Structured, high intensity, and targeted. Right, the intervention was specifically meant to address the amyloid like and inflammatory like processes that are apparent in the blood. How this impacts other organ systems, I don't know. But in terms of a first test where we've been able to apply these measures and do it in a manner where there was a high degree of control with how it was done, gives us this glimmer of hope that perhaps we can, with at least with respect to the blood, begin to reverse some of these pathologies. Now, I don't want to say, I don't want to be too over confident in these results, but they're I don't think we've seen anything quite as strong as this before, particularly at a whole blood level. And it was a lucky strike with respect to the patient themselves. The patient. Now, here's the caveat that comes with this: there's no easy access to the treatments, and that's the big problem. What I set out to do was to find open source and easy access treatments. I was kind of hoping that the flavonoids would they do everything? No, I think that would be naive to think such a thing. Is something like this helpful after you've managed to mitigate some of the primary pathologies that we've seen here? Maybe, probably. It's something that we have to look into still. There's still a lot of work to do. And in this I feel, some sense of, the struggle is worth it, or was worth it. And I'm hoping now that as the technical capabilities of the lab continue to grow, and I'm making a concerted effort to make sure that these cytokine panel measures are being able to be done in the lab currently. Now we're set up to do ELISA measurements. My goal in that instance was to be able to measure spike protein, but the Fluistar that we have doesn't do these large cytokine type panels. I'm looking at closed all my tabs now, of course. Let's see. I hope they will have pinged me an email, confirmatory email. LabX. Yes. So just log in. So currently I'm trying to bid on this system, I need help. Right? I need help with computing. I need people around to help, and I'm bidding on this, and this is a way. It's a full. There are different ways of trying to get cytokine panels, and some methods are better than others, and this particular method provides one of the broadest arrays of cytokine panel measures, and for per cost. And people are being charged hundreds to thousands of dollars for these cytokine panels, and I need to get paid to do these things, right? I still need to keep the lights on. I got to pay for the to keep the building standing. But let's just have a look at the next acquisition to go with the citation. You can see the doc's viewing habits. I'm been infatuated with this Comet Atlas. Perhaps we'll talk about that on another stream. But Luminex Magiplex. There we go. Let's just have a look at this. Wait, no audio. Oh shit! Sorry. Yeah, it is switched off. Yeah, it had CC. I'll do it again.
MagPix is a compact fluorescent-based detection system capable of simultaneously measuring up to 50 analytes in a single microtiter well. Unlike the Luminex 200 and FlexMap 3D systems, which are based on the principle of flow cytometry, the MagPix system is a fluorescent imager. The system consists of the following components. The system fluidics include the syringe pump, sample probe, and sample valve. These components are accessible through the side access door panel for ease of maintenance. The sample tray is compatible with standard 96-well flat bottom, V-bottom, and round bottom plates. Onboard dry fluid and waste containers include liquid level sensors to alert the user when the system is running dry and to prevent spillage. The heart of the system is the optics module, which includes the sample chamber, magnet, light-emitting diodes, and a CCD camera. Based on Luminex's proven XMET technology, the MagPix system uses color-coded magnetic microspheres as the substrate on which assays are performed. MagPix can perform quantitative analysis of proteins and nucleic acids in a variety of sample matrices. Here's how it's done. The surfaces of Luminex Magplex microspheres are easily coupled with a reagent that is specific to the analyte being tested, such as a monoclonal antibody, protein, or DNA sequence. When the coupled microspheres are loaded onto a microtiter plate and mixed with the biological sample, analytes are captured based on specific antibody protein recognition or DNA hybridization. The complex is biotinylated, and finally the detection molecule is attached. The samples are now ready to be read on the MagPix system. A sample probe draws the suspended microsphere-based assay into the instrument. The beads are carried by the system dry fluid into a chamber. As this is happening, a magnet moves into place to hold the microspheres in position. The microspheres settle in a monolayer fashion on the back of the chamber. Red light-emitting diodes, LEDs, illuminate the chamber, and the CCD camera captures a set of images of the fluorescent microspheres. The software processes the images and identifies the beads based on their fluorescent pattern. Green LEDs then illuminate the chamber, and if the analyte of interest is present, the CCD camera will capture an image of the fluorescent detection molecule. The software processes the image and determines the concentration of the analyte of interest from a standard curve. Once the sample has been read, the magnet is moved away from the chamber, allowing the microspheres to be swept out. The system then flushes the chamber in preparation for the next sample. Luminex Exponent software reports the results of the multiplexed assays in real time. In this way, MagPix allows the completion of up to 4,800 individual tests in less than 1 hour. MagPix is a cost-effective, versatile multiplexing platform that provides the researcher a tool that requires less sample, less reagent, and lower labor inputs than traditional testing methods such as ELISA, thereby reducing the cost per data point for testing of multiple analytes.
Yeah, so that's where we're going, or where I'm attempting to go. And again, this is results driven, and the money is a precious resource in this instance, and I wish I could afford a new one, but if we can get a functional one, and I can fix most things, then if we can get this working coupled with the citation analytics, so we'll basically be able to grade analysis options for people that need some form of diagnostic, and we can do the simple UV fireflavin test on a microscope slide, and we can and then we can step it up. We can quantify with the citation, and then we can, in this instance, it's a problem really, but for cytokines and the signaling molecules, we're going to need, you have to have whole blood, fresh whole blood, and you're going to have to find a way to get to Japan at the moment. That's getting to Japan is the only way that I can offer these treatments at the moment, unfortunately, and that's because it's dependent on the source for the stem cell factors, the apheresis. Of course, everyone's welcome to munch down on medicinals, but I can't emphasize enough how much of a significant move it is to go from what you're looking at here to here, and see reductions in amyloid microclotting in these samples. And unfortunately, well, I think the more we can direct patients to it, the cheaper it can become. Now, the relative to cord blood stem cells or autologous stem cell growth factors are a order of magnitude cheaper than stem cells. In fact, they're ripping you off with whole stem cells, I'm afraid. And stem cell growth factors, I think, pack just as much punch. And with that, I think I'll wrap up the stream. And he was asking for investment. From the Tate brothers. Yeah, man, I'll happily take investment money from them. In fact, I could reach out. I've got a pathway to get to them. If I leverage that, I just have to pick up the phone, basically. But yeah, I think that's me done. Again, I apologize for the pause in streaming, but again, it's just been too much with all the racket going on in the back, and you know, who's not going to take the chance to go and fly around a volcano with their youngster in tow? Just on a cheery note, I can just do I don't have any USB cords, do I? All right. C-type. It is. Yeah, it's pretty dope. Flying around an active volcano. I can highly recommend it. Let's just see if I can show the video. Let's do this. See, that's I'm so crowded at the moment because there was a lot of it's not stuff. It's infrastructure and storage, and that's what I was using out back for. And currently, it's all in the lab, and it makes for a very, very crowded workspace. So messy workspace. But let me just plug this in here. And I should be able to, I hope, see my phone, camera, and yeah, let's see. I think it was quite a long clip. I'll go out on this. Where's it not playing? It wants to transfer over. Go on. Nearly there. But yeah, if Tristan Tate wants to invest and help, I mean, I'm not sure what the return on investment would be, but I think this is more a, how would you say, philanthropic endeavor. And I don't know, if we get a chain of stem cells and plasmapheresis are us chains going around everywhere. Yeah, so I'll forward it a bit because it takes a while to, yeah. terrifying little helicopter. It was just, it felt like it was going to fall apart at any minute. Takes a while to get to the volcano. Yeah, I think this is us coming up. So, it's actually venting the volcano. I mean, its sort of clouds are... did I take out any wildlife? No, not in this instance. It's a better view of it venting. So we're coming up on the sort of caldera now. It stinks of sulfur. So it is water, but I presume it's very acidic, sulfuric acid like water down in the crater. And yeah, that was it. That was us. That was it. Me and the boy out for a trip. Well deserved trip, I think. And like I say, replay this stream. Let people know that there are options, okay? And again, I think there's still hard work to go or to do, but there's we can see the way to go now, and this is a relatively quick reversal of the pathology in this instance. Now we have to see how long it lasts. I'm of the opinion that it will probably be a maintenance type affair, unfortunately, but we'll see. Maybe for some people one treatment is enough. I don't know, but yeah, I'm out of here, folks, and good news to take out on a weekend. A bit less genociding going on, and a few steps forward with respect to tackling a very, very difficult pathology right now. A pathology that literally is decimating the the able-bodied. They're no longer able-bodied anymore. The death waves are being camouflaged through all manner of statistical chicanery, but I think this signal's pretty strong. This is where we should be looking, and the doc has I think, a good handle on how to fix that right now. So I'm out of here, folks. Sorry for the technical problems on the first stream, and I'll see you in the next. And yeah, don't forget, I can't do all that or take the boy to helicopter rides around volcanoes without your support. So see you